Okay, folks, I finally got my lineal motion shaft in, so I can start doing some serious work. Now, I had a bit of a setback, a bit of an engineering screw up. Okay, this is my original plate. This is 16 square, and it's 1/4 inch thick. Sorry, 3/8 thick. And you can see where the bearings would have gone. And I kind of screwed myself over because I was thinking that the router was going to go on the side with the bearings. So I needed X amount of room to clear the bearings. Okay, that was false thinking. That was a $162 mistake. All right. So even though I made a mistake, I also gained something. This is my new plate. This is 10-inch square, 1/2 inch thick. Steel, precision ground, parallel edges. And you can see I have the bearings already mounted. Now, the advantage of this plate is the fact that it's 6 inches smaller on both sides. So this will give me 6 inches more capacity on the X and Y axis. So that's the good news. Okay, the router, and I'm not going to be using a porta cable router. I'm going to be using a Festool 2200. That's a $1,000 router. And those are probably the best routers you could use for this situation. The porta cables, I've been using them for years, but I hate them. What I don't like about it is the fact that on the side of the router, there's a steel pin, and the steel pin always catches on the aluminum spiral threading. So even if you loosen the special bolt here, T-shaped bolt, a lot of times you have to take a screwdriver and stick it into the split and then turn it up and down. It's just a headache. I don't want to deal with it. Now, as you can see, some of the nuts are interfering with the router, but that's not a problem because I'll countersink those few on the top. And then what I'm going to do once I get the real router is I'll drill and tap the 1/2 inch material, although I won't be tapping the whole 1/2 inch because that's just too much work for me, and it's not necessary. Okay, this is one of the 2 lineal rods that I've ordered. Now, these are quite different than a rotary shaft. These are lineal shafts. These are not rods. These are not drill rods. And these are precision ground. And the straightness tolerance is unbelievably tight. And they're used with these bearings, lineal bearings. This is 1.25 inch diameter. So this is a big rod. Why aren't you going in there, Rod? It's very easy to slide these back and forth. This is a heavy rod, and it just works so easily. So The other components to the carriage, besides the router plate and lineal shafts, are the side mounting plates. These have the V-groove cast iron wheels that are on needle bearings. And what I'm going to do is attach the shaft to the plate. This plate is 1/4 inch thick steel, 3 inch by 18. And what I'm going to use to attach it is a split shaft collar. This is a 2-piece shaft collar. What I'm going to do is weld it and probably bolt it as well for extra strength onto the plate. And then the shaft will attach to the rod. It's not going on now because it's too tight. Okay, so that's where I stand now. And what I'm going to do now is make up some sort of a jig to transfer this, weld this shaft collar onto the plate. Okay, folks, so here you have it. I'm all clamped up here, ready to go. What I've done is I used the actual frame of the machine to act as a temporary support. So I have my 2 rods here, and at the end of the rods are the shaft supports, the split shaft supports. This end here is ready to go. I clamp the shaft support to the flat stock just to make sure that there's no gap. And then I have these extra long bar clamps, top and bottom, to hold everything together. Here is my carriage, moving very easily. So I'm going to go ahead and tack that up. We have some fun now.